everyone, welcome to Unlock Maths. Today we are going to find derivative of sin x by first principle. So yes, we have to take this f of x is equals to sin of ax, right? So we know we have first principle. Yes, we have this f dash of x limit h tends to 0 f of x plus h minus f of x upon h, right? That means we have to find derivative of this f of x by using this formula. So yes, here we need f of x plus h. So from this we have to find f of x plus h. So what we have to do? We have to replace this x by x plus h. So here we have this is sin of a x plus h. So on simplification we will get sin this ax plus ah, right? So yes, now we have to put down this value here. So here we have this limit h tends to 0. This is sin of ax plus h minus this sin of ax upon h. Yes, now we can check that here we have this form sin a minus sin b. Yes, we know what is this factorization formula. Yes, this is twice of this cos of a plus b by 2 into sin of this a minus b by 2, right? Yes, now we have to convert this sin a minus sin b into this. So yes, we have here, yes, we have to consider this is as a a and this is as a b. So yes, we will have here this is 2 into, this is cos of ax plus h plus this ax by 2 into sin of this a minus b. So here we have this is ax plus ah minus ax by 2 and this is upon h, right? So yes, we have here this is limit h tends to 0. On simplification we will get this is here cos of twice ax plus ah, this is by 2 into sin of this ax get cancelled. So here we have sin of ah by 2. This is here, this is by 2, this is upon h. Yes, so we have done simplification here. Next we can write this is again cos of, yes, again we can simplify. This is here, we will get this is 2 to get cancelled. So here ax plus this ah by 2, right? And this is sin of this ah by 2, right? And this is upon h. Yes, now yes, we can check here. Can we put the limit here? Yes, when we put h is equals to 0, yes, this cos doesn't get vanished, but when we put h is equals to 0 on this, so this get vanished. So yes, we have to adjust this formula here. This is sin h tends to 0. Here we have this is sin of ax, right? By ax is equals to 1. Yes, this is here x. We have taken variable x here. Sin x tends to 0. Sin of ax by x is equals to 1. Yes, we have this standard results. Yes. Okay, so now we will adjust here. So this is cos of ax plus ah by 2. Yes, so sin ah by 2. Here we have this is h. Yes. So yes, we need ah by 2 term here. So yes, we will write this is, yes, we have adjust e by 2 here. So that means we will multiply this is by 2 by a, right? So now we will separate the limit here. In next step we will have this is limit h tends to 0 cos of this ax plus ah by 2, and this is limit h tends to 0, this is sine of ah by 2, and this is ah by 2. This 2 by a, yes, we will take this is outside. Yes. So now, yes, we have this form here, so we can put this is as a 1, and on simplification we will get this 2 to get cancelled and this a get in denominator. Now we have to put limit, so when we put h is equals to 0, so here we will have cos of ax plus 0, and this is 1, right? So yes, we got here f dash of x is equals to what here? We can write this is cos of ax, yes, into a. And what is our f of x? Yes, this is sine of ax, right? So we got here this is cos of ax into a. So yes, we have find derivative of sine of ax is equals to this cos of ax into a, right? Where a is constant.